All right, so we're continuing our journey towards a better understanding of the base 12 version of pi by looking at the geometry of this diagram that generates all 360 degrees using base 12 geometry and the geometry of the dodecagon. So we're going to continue the same process we've been using before. We're traveling along the 39 degree line in base 12, which is in units of square root of 2, to the sixth ring of the diagram. We're going to land on a lattice point, and we use that point as the definer for our next ring of the diagram. The next circle, each ring has two circles. For the second circle, we add 0.5 root 2 to the first radius at a 90 degree angle. We find another lattice point. We draw the second circle, then we can trace those circles down to the point where they are crossing the x-axis, and we can convert their values to their square root versions, and then we can find their x coordinates, and we can see that the gap between the two circles is again getting smaller. Then we can look at the degree lines that are crossing the two circles that we just drew, and we can see that these particular degree lines were actually generated on the third ring of the diagram. So we're working in sections of 5 degrees and then 2.5 degrees. So we can use the degree lines that have already been established. We put our compass on those degree lines and make our marks on the outer circle, and then we can put our compass on those points and draw the new circles, the smaller ones, and then that works out evenly, and we can generate all of the small circles just right away, and then we can put the larger circle around them, and that gives us all of our new degree lines when we find the midpoints between them, and that carries on. You can see there's a pattern developing between the third, the sixth, the ninth ring, the 12th, and the 15th. So this is one of the rings that's actually generating the sections of degrees that are going to show up in the very final 360 degree circle, because these are all whole numbers, you know, the 5, 13, etc. So then we can go to the formula that we're using. We're dividing 26 by 20, and again we can see that we're generating in this particular ring sections of 1.3 degrees. Then we can also use the other formula, the n minus 2 times 130 divided by n, to find out that the actual angle inside the small circles is 129.6 degrees. So that's basically all the information that shows up in this particular ring of the diagram. And what we're going to do in the next video is actually look a little more closely at this particular ring, and again compare the difference between base 10 pi and base 12 pi in relation to the geometry that we're generating in this diagram for 360 degrees. So I hope you can join me for that next video. Thanks for watching.